This is lesson 4.2, continuing our journey in chapter 2 about triangles. Today we're talking about angles of triangles. All right, students, we're just working on the warm-up as a little review from 4.1, so I'm going to start going over that. Use the figure below to answer questions 1 and 2. Number 1 says classify each triangle by sides and by angles. All right, so I'm going to do my sides in blue, angles in red. Okay. First triangle PQR. That's this one. Okay, so I'm looking at their sides. They're all congruent. What do we call those? Alejandro?
Equilateral.
Equilateral would be how we classify it by its side. Good. Angles. This is a special one. Equiangular. If you said acute, it's technically not wrong, but you need to be more specific. And that this is our special one, where if we have all three congruent sides, then all three angles are going to be the same as well. We call it equiangular. Oh, my markers. All right. Next triangle. Where did I go? Triangle QRT. QRT. All right, looking at its sides. Two congruent sides. Okay, you do the angles. Alex? Isosceles would be how we classify by its side. Okay, Malin, what did you classify for the angles? You were right.
Obtuse.
Obtuse, because I see it has one obtuse angle right here. This one right here. Obtuse triangle. Okay, one more here. Triangle RST. This one. All right, by its sides. No congruent sides. Matthew? Scalene, good. By its angles. Right. Yep, I see this right angle right here. There is a right angle right here. Right. What a great problem to review over all our vocab. Okay. Number 2 also goes with this diagram. It says if PQ is 3x plus 4, so I'm talking about this one right here, and the perimeter, oh, how fun, connection from chapter 1. Perimeter of PQR, that was the one I outlined in yellow, is 57. Find the value of x. All right, folks, if this side is PQR, if this side is PQ, and it's 3x plus 4, what's this side going to be? 3x plus 4, what's this side going to be? 3x plus 4, they're all congruent, right? It's equilateral. So you can do 3x plus 4 plus 3x plus 4 plus 3x plus 4, or you could just triple that side because they're all the same. And perimeter means you add up all the sides, right? So this adds up to 57. You didn't have to triple it like that. You could have done 3x plus 4 times itself 3 times if you wanted to. All right, so if you got that far, you should have gotten x to be 5. X is 5. I like that problem. Okay, last one here. Number 3. If triangle DEF is an isosceles triangle, angle D is the vertex angle. So I did preface this earlier that means it's across from your base. That's our vertex angle. That means that this side and this side would be my two congruent. So I'll call this one E and this one F. All right. DE is 4x minus 7. EF is 3x plus 2. DF is 6x minus 15. Find the value of x and find the measure of each side. Okay. How could I set up an equation to solve for x? He's already answered the question. Guys, somebody help us out here. These four. Siler.
You would do like each sauce or the two sides that are the same.
Yep.
Do equal to each other.
Exactly. Exactly. Good job. The two sides that are the same, Siler said, set them equal to each other. And then we can solve for x. All right, I'll do that quickly. So subtract over the 4x, we get 2x. Add over the 15, we get 8. Divide by 2, we get x to be 4. If you got that far, good job. So then to find the measure of each side, you just got to plug 4 into all the x's. So I did DE first. I think I got 14. Oh, no, not DE. I did EF first, the base. I did EF first, and I got 14. And then I just plugged in 4 in for DE, and I got 9, and I recognize that DE is the same as DF, and they're both 9 units. And you can write your answer like this if you want to. Okay. That's a little review over 4.1, lesson 4.1, which we did on Tuesday. So today, we're going to talk about the angles of triangles, which we actually did talk about a little bit on Tuesday. So there's really just kind of like 2 theorems, but they're not really theorems. Obviously, you have to prove, and you guys already know this first one pretty well. It's called the triangle angle sum theorem, and it basically allows us to say what the degrees of every angle in our triangle have a sum of. So if I look at this triangle ABC, you guys tell me, what is angle A plus angle B plus angle C total up to? 180, right? That's a theorem. That the sum of the measures of the angles of a triangle is always 180. Okay, so let's just jot this down under the example that the measure of angle A plus the measure of angle B from this photo plus the measure of angle C. The sum of all those is equal to 180. That's one of our theorems for today. Okay, the second theorem is the measure of an exterior angle of a triangle. So if we're looking at this picture here, which angle do we think is the exterior one? 1. It's lying outside our triangle, right? This is like talking about the exterior angle. So this theorem says that the measure of this angle is the same or is equal to the sum of the measures of the 2 remote interior angles. Whoa, that's a lot of jumble. 2 remote interior angles, so we're talking about angles inside a triangle, and they're talking about the 2 that angle doesn't touch, kind of is a way to think of that. So in this case, I'll use my colors here again. The measure of angle A plus the measure of angle B, whatever that sum of those 2 angles are, is going to be the same as what the measure of angle 1 is. Okay, let's talk about why this makes sense. Again, you don't have to prove this, but you should understand why this makes sense. Let me ask you this question. Angle 1, and I'll call this angle C. What do these 2 have to add up to?
180.
Why?
Because it's line.
Straight line, they're a linear pair, they're supplementary, right? They have to add to 180. So if this angle plus angle C equals 180, what does angle C plus these 2 angles have to add up to? 180. So wouldn't it make sense that whatever this angle is, plus angle C, if that totals 180, and these 2 angles plus that angle also equal 180, that the measure of this angle is the same as the sum of those other 2. Okay, that's why it works. All right, let's try a couple example problems. Here we have a couple triangles, and we have to find the measure of all basically the unknown angles here that are labeled measure 1, measure 2, and measure 3. So I look at this and I see that first triangle CDE, and I'm like, hey, I can easily find the measure of angle 1 because I know that 38 and 67 in measure of angle 1 have to add to 180. So however you want to show your work here, but I would probably just do, well, my total of 180 minus what I already have, minus the 38, minus the 67. That could give me the measure of angle 1. Some of my other students last hour were liking to add these together and kind of set up an equation. I was like, that's totally fine. We're all doing the same math here. Eventually you'll be doing 180 subtracting the other two angles. We get 75 for the measure of angle 1. I like to, anytime I find an angle, write it in my picture because sometimes it helps you find the following angles. So now that we know angle 1 is 75 degrees, what can we do from there? Tyson?
We know angle 2 is also 75 degrees.
Okay, correct. Why? Nope.
Vertical.
Vertical angles. Good job. Vertical angles. They're formed by two intersecting lines, right? So vertical angles are always congruent. If that's 75 degrees, this one's going to be 75 degrees. And again, write that in because then that's going to help you find angle 3 because I see I have another triangle over there, triangle ABC. So the measure of angle 3, since those angles have to add up to a sum of 180 by my triangle angle sum theorem. So now 180 minus 48, that was given to us, minus angle 2, which is 75. We get the measure of angle 3 to be 57 degrees. Woo-woo. Okay, that was fun. Let's try one with the other theorem, the exterior angle theorem. This one says, find the measure of angle FLW in the fenced flower garden that is shown. All right, so when they're talking about FLW, angle FLW, remember L would be my vertex. They're talking about this angle right here. They want me to find that angle, but it has a variable in it. It has x. So first I'm obviously going to have to find x. Okay, so here is my exterior angle theorem. That whatever this angle is, because this angle plus this angle is 180, and these two angles plus this one is 180, that this angle right here, this x minus 24, is going to be the same as the sum of these two angles, which is 1/2 x and 16. So we can do that, exterior angle theorem. Okay, now to solve this equation, I would times both sides by 2 since I see that 1/2, that fraction. You don't have to, you can solve it with fractions if you want. That'd give me 2x minus 48 equals x plus 32. All right, subtract the x over. I get 1x. Add 48, I get x to be 80. Algebra. All right, I'm not done because that's not what I was asked to find. I wasn't asked to find x. I was asked to find the measure of angle FLW, which is x minus 24. So I would just do 80 minus 24, which gives me 56. Final answer. All right, so there's two really good classic examples of both theorems that are new for us today. All right, 2 down, 4 to go. Let's try one that's a little bit more of a puzzle. These ones are fun. Find the measures of the numbered angles. So we have angle 4, angle 5, angle 6, angle 7, angle 8, angle 9. We have to find. Holy smoke. Now, just because 4 comes first numerically doesn't mean you have to find that one first. You can find whatever one's easiest. Which one do you guys think would be the easiest to find here? You can just shout it out.
7.
7, right? 7 would be really easy to find because I know these two angles. So 7 would be 180 minus 58 minus 65, which gives us 57. I like to write it in there. All right, we could go a couple ways from there. And sometimes there's more than one way to solve these. Let me ask you this question. What angle is also 57? 5. Why? Who said that?
Vertical angles.
Vertical angles. Tech, which one do you want to find next? What angle? What number?
4.
Sure, let's do 4. All right, Tech, how would I do that?
57 plus, or no.
Yeah, you could, I mean, you could do it that way.
57 plus 67 equals 180.
Subtract that from 180. Yep. Your thinking was right there. So 180 minus 57 minus 67. Or you could add those together and then subtract it from 180. That's fine. Oh, let's see. I got 56. All right. Which one do you guys want to find next?
6.
Alejandro, we're going to say 6 as well?
Yeah.
Me too. Let's find 6. Alex, idea how you could find 6?
Add 57 or minus 57 from 180 and that would
Okay.
equal 6.
Yes, you're right. Why?
Because supplementary.
Good. Measure of angle 6. Now, you could see this 2 ways. It's supplementary with 7, right? It's a linear pair with 7 or with 5. Doesn't matter because they're the same angle. So we do 180 minus 57. I like what she said. She said supplementary. You could say linear pair as well. All right. So that I got 123 degrees. All right, I got 2 left. I got 8 and 9. Alejandro, you look like you have an idea.
I have an idea. I don't know because it's weird.
Okay.
You take, because XWZ equals 180. You
Okay.
subtract 180 from, or you subtract 123 from 180 and then divide your answer by 2.
Okay. Why do we divide it by 2?
Because 8 and 9 say they equal each other.
Perfect. Exactly correct. All right, so I'm going to say that so the microphone picks it up. He said this triangle has to have a sum of 180. We know angle 6 is 123, so we did 180 minus 123, we got 57. And then he said those 2 angles are congruent, so I got to take half of that or divide it by 2. And you do get a decimal, that's okay, 28 and a half. And you're exactly correct. Angle 8 and angle 9 are the same. Okay, that's marked in that figure for me. They're both 28 and a half degrees. How fun. Okay. We have another fun puzzle like that. And I'm going to let you guys try this one. You don't need me. You have to find angles 1 through 5. Good luck. Got this. Here we go. One more minute. Alrighty, let's do this. You guys look like you're falling asleep. Okay, who wants to tell me which angle they found first? Not everybody at once. Sheesh. Matthew?
Angle 5.
You found angle 5 first?
Yeah.
Okay, great. How'd you do that?
I did 180 minus 90 minus 41.
I love it. One angle, or 180 minus 90 minus 41. What'd you get, Matthew?
At 49.
All right, do we agree with him? Do we get 49 for measuring angle 5? Me too. You didn't have to find that one first, but okay. I like it. Alex, what'd you do?
Measure of angle 2 because I did 48 plus 56 minus 180 or 180 minus that, and got 76 because they're vertical angles.
Perfect. Okay, so she's looking at this triangle here. She said she did 180 minus 48 minus 56. What'd you say you got? Sorry, 76? She said she had 76. And then she said, hey, angle 2 is vertical to that one. So I know angle 2 is also 76. Good. Love it. Good idea. 76 degrees. Okay, we got 2 and we got 5 down. We need 1, 3, and 4. Gwen, which one do you want to do? Measure of angle 3.
I did 90 minus 48.
Oh, I like it. Okay, so I'm just going to add something here. We know this is all 180. And she knew this one was 90. So she kind of just skipped a step. She's like, well, obviously 180 minus 90 is 90. So then minus another 48. What'd you get for that, Gwen?
I got 42.
42. Do we agree, class?
Yes.
I like it. Whoa. Okay, all we have left is little old angle 1. Couple ways we could do it. Is that a hand up, Walker? No? Are you sure?
Yeah, I think you should.
What did you get, Walker?
For one?
Yeah.
I got 95, but I don't think that's right because I got another one wrong.
That's okay. And you use that one to find the next one. That's one thing that stinks about this puzzle. If you get one wrong, and then you use that angle to find the next one, you're like, oh no. Okay, Alejandro, go ahead.
34 minus 90 because of that right angle.
34
And
minus.
then I added
Oh,
I added
wait.
56 plus the measure of angle 4, which is 48. Add those together and you get 104. And that is the measure of angle 1.
Okay, wait, were you kind of doing the remote interior
I'm
angles?
talking about the triangle with 2 and 4.
Okay. Oh!
That angle and angle 4, and I got angle 1.
Wait, we already found angle 4, didn't we? Oh no, we still have to find angle 4. Is that the one you were trying to do?
I was trying to do number 1.
Okay, keep going. Sorry, I'm just not following your thinking. Say it again.
Okay, so getting the blank angle to the left is 34 minus 90,
90.
Yep. Okay. So what'd you get?
56 for
Okay.
that blank angle.
Got it. Got it.
And then 4, I don't remember how I got that.
Well, probably because those add up to
Yeah,
180.
it's 48.
Okay, let's do that one. Measure of angle 4 is 180 minus 56 minus 76, and you got 48. Yep, that's right. Okay.
Now all I did was add the 48 plus the 56 because those are the two angles, and that gives you the angle, or the measure of angle.
I like that. You did the exterior angle sum one. Yep, love it. You could have also used these two.
I didn't think this existed.
That's okay. That's totally fine. It's technically an exterior of the green triangle, and it's an exterior of this black triangle, so either is fine. Okay, so there's the exterior angle sum that the measure of angle 1 would be those two added together. It's also supplementary to 76, so you could have done that as well. 104 degrees was what we got for measure of angle 1. Okay, how we do?
Got 'em all right.
Got them? That's fun. Okay, just a couple more to go. You like this next problem. I promise. One angle in an equilateral triangle has a measure of 60 degrees. What are the measures of the other two angles?
60.
Is it that simple?
I think so. Yeah, it is. It is that simple.
Aren't all measures in an equilateral triangle 60?
Yeah.
Yeah. You have congruent sides, they have congruent angles. All right, next one's a little harder. One angle in an isosceles triangle has a measure of 72 degrees. What are the measures of the other two angles? All right, let's draw an isosceles triangle. Make it a little bigger. Two congruent sides. I'm going to say these two. All we know is that one of the angles is 72 degrees. Now, it matters where you draw it. So let's just say for funsies, it's this one. This one's 72 degrees. Okay, how could I find the measure of the other two angles? Any ideas? What do you think, Alex?
180 minus 72.
Okay, let's do that. So you did 180 minus 72, which is 108. Okay, and then what did you say?
5 by 2.
Okay, why? Why do we know that those are the same? You're right.
They just are.
If they're across from the two, if these two sides are congruent, then the two angles kind of like across from the two sides are also congruent. Okay, so you're exactly right. They could both be 54. That's one option. Now, I mentioned that it matters which one you call angle 72, because let's look at this case scenario. What if I would have drawn my picture the same way with the two congruent sides, but I said this was angle 72? All right, so based on what we just talked about, if this is 72, what's this angle?
72.
Also 72. So that's a different answer. Meaning, what would this angle be?
36.
That was impressive mental math. 36? Yeah, how'd you get that?
72 plus 72 minus 180.
Yep, exactly. So 180 minus 72 minus 72 is 36. So another answer, they could both be 54, or one could be 72 and one could be 36. It's kind of a fun problem. I would accept either answer, and you don't have to have both. Either answer is correct. Okay, that's a wrap. Wow, another short lesson.
I learned a really fun thing to do. I think it's important.